So let's look at a new topic. Now we're going to start solving systems of inequalities. Now, a system, remember, is more than one equation, or in this case, more than one inequality. So we're going to take two inequalities, we're going to graph them on the same axis, and what's going to happen is when you graph them on the same axis, there's going to be some overlap. And this overlap is what we're concerned about. It's because this overlap, the region that it works for both inequalities, is the solution to the system of equations. So if this was our graph after we did all our work, the region right in here is the overlap. That would be our solution to our system of inequalities. So let's look at one. So what are we going to do to graph a system of inequalities? Well, the first thing we're going to do is we're going to treat these like equations. So we're going to take the first one and we're just going to make it the equation 2x plus 3y is equal to 6. Now, how do we graph that equation? Well, we spent a lot of time graphing equations. On this one, I'm going to use the intercept method. So let's do the x and y intercepts. And when x equals 0, we can look at this. We're going to get 3y is going to equal 6. So our y value is going to equal 2. So x is going to equal 0, y is going to equal 2. When y equals 0, we get 2x is equal to 6, and x equals 3. We have an equation. And we go to these points on the graph, 0 on the x, 2 in the y, and we're going to 3 in the x, 0 on the y. And what we're going to do is we're going to draw in a line. Now, remember, when you're drawing in lines, you want to use a ruler at all times. Now, I'm going to try and do my best on computer here because it doesn't work out as well without a ruler. But what we're going to do is I'm going to put in a third dot, go rise over run, and we're going to try and draw in a straight line, just like so. Now remember, inequalities, they act like the boundary. So this is the boundary line. So we want to determine what side of the line we're going to shade on. So how do we do that? Well, we pick a test point. So let's test 0, 0. And when we test 0, 0, we're going to get 2 times 0 plus 3 times 0. Remember, we're testing it in our original inequality is less than or equal to 6. So is 0 less than or equal to 6? This is a true statement. If it's a true statement, then we would shade where the test point is. And if we can see that our test point would be at 0, 0, so we're going to shade the region below the line. But, here's the big but, we don't want to shade it yet. Because we're dealing with a system of inequalities, we don't want to shade all of our area yet. And what I'm going to do, and the textbook doesn't show you this, but here's a little technique that we can do to indicate. We want to shade below this line. So what I'm going to do is I'm just going to put some little arrows to indicate I want to shade below this line, everywhere below. I'm not going to shade it, but I'm going to say I want to shade that. So now we're going to look at our second equation. Now this one is already in the form y equals mx plus b when we put it into equation. So let's just make it an equation, and we're going to have y is equal to 2, and I'm just going to change it so I can know my slope, 2 over 3x minus 2. Remember, that tells us that the intercept is at minus 2, and there's a slope of, a slope of 2 over 3. So we rise 2 and we run 3. And we put a point. And we rise 2 and we run 3 and we put a point. Now, remember, when we're dealing with inequalities, we always have to be careful about what type of line by what this inequality is. This one is equal to. This one is equal to. So what that means is if they're equal to each other, we want a solid line. So we're going to draw in a solid line. Now, once we have our inequality, remember, we always want to determine what side of the line to shade on. Now, here's something that's really nice. If we have y is greater than or equal to, and it's in this form, y equals mx plus b, the greater than or equal to tells you that it's always above the line. So that's where we want to shade, above this line. Now, we could pick a test point. There's nothing wrong with picking a test point, but there's no need to at this point to verify. If you want to, go ahead, you could put a test point in there and you'll determine that, yes, we want everywhere above the line. So if we want above the line, we're going to do the same thing we did before and draw in these arrows. Now, we can see where the arrows overlap. There is only one area that the arrows overlap, and that's this area right in here. So once we have all of our inequalities drawn on the line, we just shade in the region that contains the overlap of our arrows. All right in here. Make it very clear. So there's our solution to our system of inequalities. So how do we do that? Well, these are the steps we followed. First thing I did is you graph it like an inequality, the inequality like an equation. Now that hasn't changed from one inequality to a system of inequalities. Step 2 is choose test points for each inequality, and that's the big thing to remember, that it's each inequality. So we're going to test each inequality separately. Once we have tested the inequalities and determined where they are, we're going to mark the region to be shaded, but don't actually shade them. And remember, that's where I marked that region with those little arrows. Step 3, take the final answer as the overlap of all the shaded regions and shade it. So this is the area where all of these arrows overlap. So if you follow these 3 steps when you're graphing the system of inequalities, you can do any inequality thrown at you.